All right, good afternoon. This is Common Ground. It is 3 p.m. in the afternoon at BSides' 10th Las Vegas conference. Just a few announcements before we begin. First of all, as always, we have to thank our sponsors who, along with you, by participating, make this possible. This year, our Inner Circle sponsors are Critical Stack and Valimail, and our stellar sponsors include a number of great companies, but to pick three, we'll thank BlackBerry, Silence, and Paranoids. Before we begin, just a reminder that these talks are streaming, so if you could make sure your phones are off. If you have questions, make sure you answer the microphones. Thanks for your participation. Please welcome our speakers, Pedro and Rodrigo.
Woo. Hey, good afternoon. Do you hear me? Or I guess, yeah, you hear me. Cool. So welcome. This is the Contemplator approach. Is a tale of data enrichment through Elastic. Pura vida. I don't know if you know that, but Pura vida means that we are from Costa Rica. So yeah, we like to feed our crocodiles. And this is Pedro.
Yeah, I'm Pedro. So I graduate from the Costa Rican Institute of Technology.
And I'm Rodrigo. I'm Platinum in Dark Souls and Bloodborne, which is equivalent in hours spent. Invest. We work for National Instruments in Austin, Texas, but we live in Costa Rica. So what are we doing here? What are we going to start talking about is all the data sources. I'm not going to explain what is a next generation firewall, what is Netflow, what is CDR. Look those as a data source. Those contain fields. When you start getting the logs from each of those tools. Those fields might be IP addresses, phone numbers, domains, agents, protocols, methods. And what people is normally doing, they are using those fields, creating visuals, reports, dashboards, alerts, and even machine learning jobs. So what we are covering here is the green part, which is the enrichment. And we are using 3 buckets to classify the different enrichment that we are going to apply to the different data sets and different data sources. For example, format, intelligence, and labeling. That's something that we are going to speak later in this presentation. And we are doing that for 1, correlation, and 2, to tell more than what the log is saying.
All right, so when we are planning to send our logs to a certain platform, whatever platform you want to choose, we have to consider diverse types of data sources. For example, we have DLP sources, VPN, web filtering, next generation firewall, gateways for email security, etc. These are some of the examples, especially when we're talking about information security. So we get all of this as an input, and then the output is something you choose. In our case, we are working with the Elastic Stack. So I will give a brief overview of how the Elastic Stack works. The idea is that we have a central search engine platform, which is Elasticsearch. So Elasticsearch will be the one in charge of all the data. You can do the search through there, maybe through an API, or using Kibana. Kibana is the front end where you can manipulate or generate analytics from the information you have in Elasticsearch. So this Elasticsearch is what is central through the whole stack, but with the addition of Kibana, pretty much is what you're going to use for analytics later. Then, where do we get all this information from the input and send it through Elasticsearch? So we have 2 things here that works for you, which is the beats. Beats are single-purpose tools that, for example, they grab information from ports, TCP, UDP, even Netflow ports, Netflow information, sorry. Then we have what is Logstash. Logstash is a multi-purpose. It has lots of plugins where you can connect some kind of input you need, process all the information, and then send it to whatever output you want to work with. Logstash is not mandatory to use with Elasticsearch. Logstash you can send to another platforms. So the data enrichment part will be focusing on using Logstash mainly, and the analytics part will be mostly related to Kibana. So, all right, we're sending all of our logs to those platforms, but when we are sending those logs, we're just getting this one. You open the interface of whatever analyzer you're using for this kind of stuff, and you just get, okay, there is the flow of the data we're getting from the last 24 hours. This is a list of information we're getting from it. We just expand the documents and see what's there. Okay, that doesn't say anything at all. It's like, we just have documents, but we are not doing anything regarding, okay, this means like, this happened here and this is related to something. No, this has no correlation at all. This doesn't have any context at all. Some people even do some dashboards, but not as advanced as the ones shown in the picture. Maybe they just have a list of things. They just have like a bar chart with a date histogram, and that's it. They don't do more analytics from this. It's something pretty simple. So what happens here is that also all the tools may not speak the same language, or what is something for this tool has another name of another tool. So for example, maybe you have a field called source IPv4 for X tool, but in the other one is source IPv4 yada yada. They mean the same thing, but when you just receive those logs, you don't change the name, or you don't find a way to find a common ground between them, you're just getting two different fields that maybe you cannot do correlation at all from them, and it's not useful for you. And there are lots of cases. We have a huge list. For example, this list here is one of the examples that we dealt before, like trying to find a common name for each field by grabbing all of our sources and then classifying them. So why enrichment? So what's the importance here is that we want to correlate like events that are happening in one source with the other may help you with better incident response or having an idea of what's going on. Then we have the context. Again, the idea is you get more of your logs. You have a better panorama of what's going on. And then the analytics for if you need to do reports, you have to search, all right, somebody is going to see your platform and work on your platform, having those analytics ready, and in the way they can understand and do very advanced search on it is a huge plus to detect any kind of issues later.
So we are going to cover this in three parts. The first one is theoretical. So it's going to be very boring because I'm going to try to explain what we are trying to achieve theoretically. And then we move to the technical part, which is the magic that Pedro is making with the scripts and repositories and all the things that I don't understand. Okay, so Contemplator approach. So we have the data sources, we have the fields, we already covered this, the different values, and then to start explaining this, let's use three buckets. Let's use format, intelligence, and labeling. So in format is everything related to the format of the field. If this field could mean something that is already a known value, using dictionaries or even taking a string and fractioning that string in different values. Then we have intelligence, which is external information we are going to inject to the logs we already have, to some fields in the logs. And then labeling is known values for us that we are going to start tagging. So this log, for example, it's coming from an administrator in Azure Active Directory, so I'm going to tag this as an admin log. So let's start with the format. Common name. So if you are ingesting in Splunk or Elastic or any other tool, CDN logs, for example, Content Delivery Network from Cloudflare or Akamai, and if you are also extracting logs from a web server, let's say Apache, they both contain the same true client IP, which is the IP of the client that is making the request. And the CDN will call it client IP, and the web server will call it true client IP. So the meaning is the same. It is the same IP, and you can correlate that, but the field is separate. And this is really basic, but most of the time people are not removing or modifying the field names. In this case, what we want is to call it the same if they mean the same. Known format for this, if you are processing IP addresses, then make your Splunk or Elastic understand that field as an IP address. There are plugins for that, because sometimes you are not interpreting that as an IP. It is just a plain a string, and you are not able to query based on CDR notation, for example, CDR ranges, for example. The other part, a cool one that I don't know if you guys know, is the E164 numbering. That's for phone numbers. So that's basically taken from call data record CDR from call manager, and it is taking all the phone numbers and it is enriching those in a format that you can read easily. Basically, the plus, country, area code, and the rest. Dictionary. This is about known values. I'm going to explain this with an example. If you play with Netflow, raw Netflow, you see that the Netflow TCP flag is hexadecimal. So why you keep the hexadecimal? I mean, it is easier for us to basically move from the hexadecimal value of TCP sing to the word sing, and looks pretty in the dashboards, and it is easier to manipulate. Also, another example in Netflow is the IP protocol number. So it's hexadecimal for the TCP protocol or the IP protocol, and you see the number there. Just enrich that with what it means, which is TCP, ICMP, or UDP. The other one that I want to mention in the dictionary is there are repositories that will take your user agent from from Apache, let's say. They take the string from the web user agent, and they convert that to, for example, in this one, you see Mozilla's 5.up and a string there that it is not telling you much. But then if you enrich that, you will resolve that as Chrome 18 on Android, Jelly Bean, Samsung. So it's giving you the browser and it's giving you the platform. Decompose, in this case, we are taking the URL and we are looking at the URL at different, we are taking the slash, and each slash will be now a field. And perhaps you're like, why you're doing this? Because it is easier to look if botnets are targeting specific sections of the network, you will see it spikes in different URL sections. That's an example. The other one is pricing, but we will cover that later. Intelligence, this is the second bucket. So geospatial is basically taking the IPs and the phone numbers and enriching that with the location. A lot of times people are looking at the logs and they see a public IP. They take that public IP to ARIN or AppNIC or RIP or whatever, and they look for the owner of that IP. Why you don't do that automatically for every single log that contains a public IP address? Identities, same. You're looking at IP, you want to see who is the registrar. Instead of doing that, just enrich that data. So every time you have a public IP in whatever source, add the geolocation and add the ASN number based on BGP. Pedro will cover how to do it later. Security and others, use the intelligence you receive from US CERT, from New Zealand CERT, from, I don't know, every country has a CERT, if you're subscribed to it, and get all the IOCs, the IPs, domains, start creating a repository and start enriching your data with those. So if you see a hash and you are collecting a hash, then start enrich that. I started wrong. So if you know, and if the US CERT send you a list of IP addresses that are related to a North Korea thing, just take that, create a dictionary, and enrich that with your current data going forward, and also, if you can, retrospective to see the past. Labeling. So in the labeling, we have different approaches here, and most of them are based on the previous enrichments. So flow direction. If I want to see inbound and outbound in Elastic or Splunk, what I'm doing is I'm taking the private range of my private range, or even my public range, and if it is in source IP field, then I tag it as source company, or it's my source. If I see it in the destination company. So if I want to, this is an example, if I want to see company source, but remove company destination, I'm asking to see outbound traffic. Yeah, or no. Yeah, outbound. Okay, IOCs, same example, takes Cisco Talos information from blacklisted IPs. It is available. You can go to Cisco Talos and see the blacklist domains and IPs. You can download that every day, every hour, and use that to label as IOC from Cisco or IOC from Talos each time you see that IP in your Netflow, in your next generation firewall logs. Compliance, since you are enriching the data with the geolocation, now you can see traffic from embargo countries. So sanctioned destinations, everything related to Cuba, Iran, North Korea, Sudan, and Syria. You can look for emails coming from those countries, flows coming from those countries, or even traffic in the website coming from those countries. You can, since you are adding the ASN number, which is the owner of that IP, you can even start tracking for the embargo companies, the entity list. Business intelligence, this is just tagging based on competitors, investors, and clients. And this is because you are now able to move from an IP to who owns that IP. And now you can, if you start tagging competitors, investors, and clients, you will start looking at them answering like, what are they doing in our website? So if you want to see a competitor, you just filter by the competitor, and you see all the activity they are doing in the website. People, similar. In this case, we are going to, since we know the email addresses and the accounts of the C-level and also the system administrator, we are going to start tagging as admin log each time we see a log containing that string. Starting with this is kind of difficult. So I base everything in Excel at the beginning. So for example, you see all the data sources there, and then the different categories, subcategories, and what I want to achieve with each of them. So for example, if I want to say IP, which data sources include an IP? All of those. And now let's see, geospatial. Which data sources can I enrich with geospatial information based on IP? And I start marking an X in all data sources where it applies. This is just a map to start like, okay, I want to enrich, where do I start? This is an example of the IP base. So I have the different IP formats, the data sources, and the description of each field containing an IP. Then at the end, I'm suggesting a change of the field based on what it means. So look at all the different numbers, different names, a value a field might have. And in the last column, you can see that actually they might mean the same, and they need to be changed in order to correlate and to facilitate the stuff. And then start marking with X, like where or which enrichment applies to this. For example, geolocation, every single IP, public IP. ASN, every single public IP. Flow direction, so if the source IP is private, then mark it as your company source IP. Same for destination. If it is public and it is within the embargo countries, then tag it as embargo. Same with competitors or major investors or clients. And also, the final one, if it is public IPs, then also tag it using the intelligence you're receiving from the external world related to IOCs. Yeah, I told you that was the theoretical part. So
let's get practical here. So you see that Rodrigo simply designing everything that he wants. He will going to analyze this data later. So you have lots of requirements that you have to keep up and try to implement them on your platform. But you see there's lots of sources, there are lots to implement, and you think, well, this is very overwhelming because where should I start? So you may feel like overwhelmed, but in the end, if you go step by step, everything starts with a simple step, and then you think about what other choices you have to implement this idea and improve it.
That's how I make you feel?
Yeah, you make me feel it. This was like the first days.
Okay.
But okay, so to start, everything you can find on the net can be useful for starting this up. Like when I was in college, there was something like everyone was pretty lazy to do the stuff on their own. If there was something on the net, okay, there is something done. We may try to use that. So we have lots of sources where we can retrieve information like lists, products, or whatever you can connect with the platform. So for example, public repositories beyond GitHub, GitLab, they have like lists or scripts that may help you to retrieve the information, maybe save it on a file for later being grabbed by one of the beats that can read a file, or just an API that you can contact with through Logstash and retrieve all the information. So there are also newsletters or trustable sources where they, for example, each day they update the list of IPs that are related to a certain malicious activity, coin mining activity. So maybe in this case you just have, okay, I just have to adapt this list, but it's a simple task. I just download this list, create a small script to adapt it to a acceptable format by Logstash, and that's it. Then, for example, for the GeoIP part, we use MaxMind for this. They have GeoIP databases that with the IP, you can retrieve where it is located, what is the ASN. ASN means like if this IP is from a company like Microsoft or Amazon or whatever. So if you can just narrow what you need, like, okay, Rodrigo asked this, maybe I should look at this and try to narrow all your research before doing everything, you will find very good results. Then again, Logstash. Logstash has lots of filters to apply. So doesn't matter where you are trying to retrieve the source or what you want to get to enrich the data. Logstash may already have a filter for this. So for example, maybe you want to retrieve information from a certain database. Logstash offers a way to connect with a database. You specify what kind of field you want to compare. Then it contacts the database, and if there's results, it will generate a new field with the result it found. So when you try to work with Logstash, it works in a very simple way because generally they work through plugins and they are written this way. So you get the plugin, you specify which attributes of the plugin you want to use, and that's it. Generally, you have a set of plugins that will work like in that has its workload. All the documents that are related to, let's say this is Apache information. So I want to apply to this Apache information all these plugins, like for enrich the data. And that's it. It's very simple to use it. There is enough documentation to understand how it works. So it's up to you to see what suits you for what you need and then apply it. And okay, it comes the point that, okay, Logstash didn't work for me, or what it offers isn't enough or cannot do what I have been asked. So Logstash offers something like, which is the Ruby plugin. So if you're not familiar with Ruby, the Ruby language, is not a difficult language to learn. When I didn't know Ruby, and when I had to do some tasks that are related to like very complicated stuff that I couldn't do with just one plugin, I had to learn Ruby, and in 2 weeks I had the basics already done, and it was kind of easy to code from this side. And all right, you may not have a background in coding. Maybe you can get whatever, I don't know, a programmer from another area and just, okay, Can you please help me with this project? It's not something complicated to do. So there are cases that we had to do something that, for example, one issue with Elasticsearch with nested fields is that it doesn't process them well, or is not that well supported. So there was a time that with one of our sources, we get like the list of vulnerabilities after doing like a scan of the machines. And we only get the score as a number. But we wanted to classify them through the CVSS, like, okay, this vulnerability here has this score. It is a moderate. It is moderate. So this wasn't on the logs, so we had to do it. It was kind of easy to do because how this plugin works. So you get, it works through simple CRUD actions, like you get a field, you set a field, you can delete a document, you can clone them, and even tag it. So in this case, we just needed to grab the field where the score was, and from then we have to compare with a range like here. So if we just compare, okay, this number associates with a height. So we just need to create a new field that will show the result of that script. So for example, something got into, there was a document that was showing a vulnerability of 9.1, which should be high. So the script will just grab this number and then convert it to the CVSS. And doesn't matter if it's a list of 100 vulnerabilities, it will do its job as expected. And also something to add is that if you're kind of worried about, okay, maybe this script doesn't work, or maybe it will crash the whole Logstash application, there's the possibility that you can just run unit testing on it, which is a good practice. And then you can say, okay, maybe if I put this case here, let's see how it runs as expected or not. And then you can get sure of, okay, this script works as expected. I think I can just run it on Logstash. So you can get really sure of what you're coding in this case is helpful and working for you.
Yay. So let's put all together. I'm going to show you examples in dashboards with the enrichments, and then Pedro will explain how he is doing that. So analytics. So let's play with Netflow. Since I'm enriching the data I'm removing the hexadecimal, and I'm asking TCP, and I'm removing the TCP numeric value and resolving as TCP, hexadecimal value for TCP flags, and resolving as what flags are there. And since I'm tagging for private versus public IP addresses, I'm able to say, okay, in this case, give me everything that is TCP, everything that is TCP flag, and everything that is not coming from NI source. So I'm looking to inbound traffic on Netflow, TCP things. What I'm trying to do here is to check all the scanning activity, people scanning our network, our public ranges. And also, I'm enriching that, the source IPs, with the country they are coming. So you can see, for example, if you see weird activity from a specific country, you will see the spike there. Same with companies. Most of them will be ISPs, but you will see if you are under DOS or somebody is scanning your network, you will see a spike not only in source IP addresses, also in who owns that IP. We are doing the same thing for Bluekeep, so we want to see if something is messing around with RDP. So after we enrich the data, I'm asking, okay, in Netflow, everything that is TCP, everything that is SYN, anything that is not coming from our public IP, private IP ranges, and the destination port is 33089. So I'm able to see what's the RDP activity, and if I switch this to give me just the NI company source IPs, targeting company destination IPs, I'm asking to give me all the internal traffic. So I'm looking for who is scanning RDP. Same for WannaCry. You can set it as SMB, and you will see who is scanning on SMB port. and that is useful to detect malware outbreaks.
So how do we do that? In this case, we're doing comparing with a dictionary. So we have dictionaries that includes, for example, the code of and the protocol that is associated. Generally, as Rodrigo said, the logs comes with showing the number for the TCP flag or the protocol there that is contacting. And so we have to do simply is just compare with those dictionaries. Okay, it came a 15 as a protocol, so it will show an XNet as a result. The same happened with the flags. We had the list of flags there. And when it's related to the flow direction, what do we do here is that we know some IPs belong to our company. And what we do is, okay, for all the IP fields we have, we just need to do like the IPs that start with this specific pattern. We know it is they are internal. So we just indicate, okay, please tag those IPs. Same for any other IP you want to start tagging. You just need to find a pattern for it, and then you just tag it as you need.
So basic data loss prevention, for example, what I'm doing here is I build a dashboard just to count or to assume how many bytes are going from my company to the external world. And since I'm enriching that data with who owns the external IPs, I can say, okay, Microsoft is normal here, Google is normal here, Dropbox is normal here. So I can start like monitoring per IP who is sending data to the external world and how much data. And the cool part of this is it is very basic just to check the data that is going out, I mean the amount of data. But the purpose of this is to filter or to remove known destinations that your company use and focus on those weird activity that happen that perhaps somebody is sending 30 gigabytes to ISP in Hungary. And we have no business in Hungary, so let's investigate that. Oh.
So in this case, the magic of the GeoIP databases is that you indicate what kind of a field with an IP you want to use to check. You connect a GeoIP database to it, and what you will get is this information right here. So you get the name of the company, where is it located, the coordinates if you like to work with visualizations that are maps, they are very useful. So you can get, they can pinpoint where specifically it's located on the map. And that kind of information is also useful if you want to just do an analysis through the time zone and the region code, etc.
Let's talk about, okay, content delivery network and web servers and e-commerce. So this is security analytics for web. What I'm doing here is splitting, the enrichment is the format and is decomposed. So what I'm taking is the URL that is actually, one second, over here. And I'm taking that value and I'm splitting the value in 4 different values. What I'm trying to figure or to detect is if there is a bot or somebody focused on a specific section of the website. For example, the search part. If you start getting a lot of gets to the search part, you will see the host or the section on that of the URL. For example, could be the 3rd section, a huge spike there in that section.
So this one is pretty simple. We have the URL. We know that each time there is a slash, we just want to separate it. So what we do is separate the URL into different pieces. The idea is that we are only interested in the 3 first. The rest we will group into a single field. So for example, we have this URL that is PSP nav add search. So we get divided. But in the case there are more than 5 spaces, we get WD rest content 1.0 and then the rest. that is not useful for us for keep doing a deeper search. But again, the idea is that we just grab the URL, separate it, and just manipulate as you need.
So we continue in security web. We are using here format dictionary. So in this case, we are taking the string of the agent and resolving that as a readable agent. Intelligence, what we are doing is downloading the list of bots, known bots and crawlers, and we are comparing the web agent with that list of bots. So the first chart is just the regular string, and this one, it is in our web server monitoring, is the behavior from known bots.
So what do we do here is simply there are lots of resources where we can grab those user agents. So for example, there is a GitHub repo from Monparis that he updates the list of user agents in a frequent way. So you don't have to worry about, okay, I have to do it by myself. No, I can just grab this repo, check for updates, and then download it. Or if I have to update it, adapt it, I just adapt it to our needs, and then transform it. In our case, we work with YAML dictionaries. So we just adapt it and generate the dictionaries, and then we connect on Logstash and say, okay, this field here is a user agent. I want to compare this user agent with this dictionary of user agents I have, and then I will get a result from it. So this is a simple example here. It's just as translate. We have the field agents. We indicate the destination, and then we indicate where is the dictionary located in our server.
So this is labeling. Let's talk about email security gateway. Perhaps in this case, you have sensitive high value targets in your company, and you want to start tagging those. So in this case, we are taking our email security gateways, and each time the recipient is a C-level, we are going to tag as C-level. And what you can do with this is basically look the behavior of the C-level if he or she clicks on a link, and also you can create an elastic watcher alerts, because it's not the same thing whether an employee hits on a phishing link or your C-level, let's call the CFO or CEO, they click in a business email compromise link, for example.
This case is kind of complicated because this is an internal source, and we have to get the list of all C-level personnel. We have to be aware of when, okay, somebody is new at the company, is our new CFO, CTO. We have to update this list, update with the people that is not working anymore. But the point is, we have this list, and we indicate, again, through a dictionary. So, for example, if there is a click reported by some C-level, the logs will indicate, okay, the recipient was this C-level, this was a click, please tag it as an urgent thing. So we receive the alert from this, we can start acting immediately.
Okay, same with C-levels. Now we know our admins in Azure or in next generation firewall in Azure or even in the Active Directory. So with this, I can start tagging. I want Elk to show me every single log related to an admin. And it will show a lot of logs because Servides, for example, they will be enabling accounts or disabling accounts every day. But then with that tag, you can specify in your machine learning. And okay, machine learning, start looking at each individual admin over time, what's the behavior, because we are able to filter those admins by this simple tag, and start looking at just what they normally do, and alert each time they do something that is abnormal for them. It's not normal.
This one is pretty much similar to the previous one, but now in this case, we're just working with admin access. So again, we have a list of people that are considered admins, And from them, we just monitor the activity from each source and detect, okay, in this case, we have this login or this information modified by this admin. So it gets tagged with the admin information.
Okay, blacklist. In this case, I'm using the tag NI source IP. So it's our company. I'm looking at Netflow. I want to see every single internal IP that complies with the tag destination Talos. That means that we are downloading information from blacklisted IPs in Talos. We are enriching the destinations. And I'm asking ELK to show me every single private IP inside my company that is contacting blacklisted destinations. So perhaps one or two TCP connections is not enough, but if I see a spike in either bytes sent, bytes received, or amount of packages exchanged, then that's when we start investigating. Most of the time it's malware. Other ideas is serve reports. So if you are subscribed to CISA or US CERT, you will start receiving a lot of reports from them. They contain IOCs, indicators of compromise, that they are in this format. So you can start building your own dictionaries and start taking those values and enriching every hit on Elastic.
Yeah, so as said before, the idea is that we have lots of dictionaries that we collect and try to update daily. And the point is, as we are just tagging that, comparing, okay, this URL is on this list, we just tag it as malicious activity or coin miners, for example. And that's it. Simply, we just have a list of plugins that are in charge of just tagging them all.
Okay, compliance. In this case, I'm taking email security gateway, Active Directory, Office 365, let's say, and called it the records, that's phone numbers, and I want to see every single login success for an embargo country. If you take that information, if you see a login success and you take that to your company's lawyers, that will cut their attention and start investigating. Same with phone numbers. If I see a call to an embargoed country that lasts over 1 minute or 2 minutes, that's something that needs to be investigated.
Yeah, this one is pretty much simple because we have a list of countries. Generally, you may say China, but on these databases, it doesn't show us China, but People's Republic of China, for example. So what we use in this case are the initials or the 2 letters that represent each country to do this detection. So simply, if there's traffic coming from this country, we just tag it as is an embargoed country.
Okay, this is the same principle with splitting the URLs to see the content, and I'm asking Elastic to show me the embargo countries, which content of the website they are going. Same could apply for business intelligence, where instead of tagging, okay, so I have the country and I have the owner of IP of the IP. So instead of, I can start enriching Elastic with, okay, tag every single competitor or every single major investors. Now I use that tag and I start looking at what specific content in the website they are looking. Even you can start looking at the different products and the currencies they are trying to get. And it is a normal activity everybody does. So,
yeah, so there are stuff that still is not, there's not on the web, or there's nothing Elastic has done yet. So you can just start doing by yourself. In this case, I'm trying to create a filter that detects E164 numbers. It detects if they are complying with the standard, and if they comply, you get like what kind of country it belongs, region, the original, the local number, and the international number. So it will be useful for if we are doing all this geolocation analysis. This will be helpful now to apply for example, detecting scam cases from other countries. So this is mostly how it looks like. The idea is that when you get a number, it will show you, okay, this belongs to this is the country code, whatever.
So this is other ideas that you might find interesting, or I'm curious for this. So the API.ftc.gov that will give you the early terminations, which is when a company is acquired by other. So it is going to give you the acquiring company, the acquired company, and the acquiring party. So, well, I'm not. That is business intelligence, because sometimes that is not public, or the press does not release notes on it. So if you have your major investors or your competitors tag, then you can use this to accelerate when the business intelligence group, to send that information to the business intelligence group. So if I have a major investor that they just acquire a company, or a competitor that acquire a company, and it is now publicly here, but it's not in the news, then I'm going to use that information to send it to the business intelligence group. And they will start looking for which is the industry, what's the sector, why they invest in that place, why they invest. Other ideas, you can take the phone numbers from the CDR. This is coming from the call manager, and you can start using white pages, though you have to pay. You can start enriching that information, the phone number, with the type and the carrier. So the type could be a mobile, could be home, business, and the carrier, which is the provider in a given country. The other thing that I would like to do, and it is really difficult, is in the content delivery network, CDN, and the web server and e-commerce. So you have the ASN using BGP. You get the owner of an IP. I want to remove all the ISPs, and I want to start looking at traffic coming to your website, or coming through the CDN or through the web server. I want to see that traffic based on sector, based on industry, and based on sub-industry. And that will be a huge query, a great query to see, okay, these are the list of products, and these are the companies that are looking at those products, and these are the different sectors, industries, and sub-industries that are looking at those. Basically what we cover is, well, we talk about several different data sources. I'm pretty sure you guys have some of those, or more than those, and how, using 3 different buckets, we are trying to enrich that data. And I guess in this, we are open to questions if you have. Oh, yeah. Oh. Oh.
Oh, sure.
On your elk stack, did you see an increased performance need while enriching this data? And if so, what was like the performance hit that it took to enrich this data?
No, we haven't seen any hits on the performance when applying this. Generally, maybe it is mostly related to the input that you're sending to Logstash. If there is too much data and you're trying to do all this enrichment, it will be kind of complicated. But okay, we have seen some cases, but we've had to discard it because, for example, it was trying to interpret from Netflow all the internal IPs related to internal DHCP server and getting the host name from it. It was pretty much a very complicated task for Logstash that simply crashed it. We just had to discard this one, but it specifically is because of the input we are getting from it. It is too much data that needs to be processed each document, and it's not a good idea.
So it looks like in your Elastic Stack here, you have a lot of dictionaries that you're manually maintaining and updating. can you talk a little bit about the automation or some of the CI/CD or user interfaces that you've developed so that other teams and groups can go in and help you enrich that data? Or is this really like a small team that's managing a whole bunch of dictionary files?
Right now, it's a small team that is managing everything. It's doing it the simple way, like, for example, again, we get those files from different repositories. We just look, okay, this is JSON. It provides us these fields here, but we're just interested in this field here. So we just create a wrapper that just say, okay, we retrieve this JSON. We want to generate a YAML file that, okay, for this IP, please tag it as this name, you know. But it's very simple, and there is no complicated task being done here, just like as a wrapper in this case. And we try to automate this like in the way that each hour for certain sources, because there are the sources that you have access in 24 hours you have limited access to it, so you have to regulate like, okay, I have to do this one time per day or one time per hour. It depends on the source in this case.
Some of your use cases involved Netflow data, and I was wondering how the Netflow ingestion works, because Netflow is always changing dynamically. If there's an ELK database that also changes dynamically, or if it's doing like a log line to record type of, like, is there a new? You understand?
Yeah, I get it. So with Netflow, what I like from Logstash is that they offer at the beginning, without the bits haven't progressed that much. They offered a codec for Netflow. It kind of did its job. I mean, it has support for providers. For example, it didn't have support for Viptela before, but you just enter in contact with the plugin developer and, okay, if you get this information, documentation on how can we interpret Netflow coming from Viptela, maybe we can just apply on the code. And after this, we really release a new version of the plugin, and that's it. You're getting now Viptela logs being recognized by the plugin. So Logstash already offers this, and now FileBeat also has the possibility of recognizing Netflow data from it. Now on the version they even, as Netflow is sending too much data, they even offer now new features like you can compress the received data to just filter what kind of information from each Netflow document you need. So you don't have to, in question of storage, there is now compression that gets pretty much easier to do queries as you're just filtering what you need now. You don't have to go through all the documents and, okay, I need to check everyone. No, you just can filter it and get what you need, right?
We don't have more questions. Cool. Thank you.